that you've got this tutor center that's open 40 hours a week in Wexler PS8. That's the basement 21. I know that some of you may have gone and had a bad experience, so I just want to remind you there are dozens of tutors that have hours there throughout the week. If you go and you have a bad experience, just find another time that works in your schedule and keep going until you find people that you like, because there are many, many very good tutors that will be very helpful for you in this. Okay? So don't let one or two bad experiences detract you from using this amazing resource. What other class in college do you have that has a 40-hour-a-week tutor center just for that class? Okay? So you can just go and just do your homework and never ask a question. And then just have the support there if you need it. Or if you have a couple questions, you can go, ask your questions, and leave. Use it as you wish, okay? Use it as you wish. Okay, but go check that out. Take advantage of this very important resource. I'm going there after class for an hour today. Okay, next thing, web work. So I reopened the web work for the one that was due today for another 24 hours. And I gave more attempts on some of these that were causing more difficulty. And we're going to talk about domain here for a couple minutes. So let's do that. So now that you've dug in and you tried to answer those questions, and now that I'm going to talk about it, this should bring you to a high understanding when we're done. So not because you'll know exactly what I'm talking about. So this function here we found was for the volume. So if I call it, say, g of x, and we spent time to figure out that rule that gives the volume for any side length of a cutout. And let me just say, it's not about memorizing this rule, okay? It's about if you had a situation similar but different, could you generate the rule, okay? Could you figure out what the rule is? That's the skill that you want to have, not that you memorize this formula, okay? But, so this was our function definition. Remember all the elements of the function definition. What's the name of this function? G is the name, okay? What is the input or independent variable? X, and that's the side of the square cutout. Side length of the square cutout. Okay, what's the output or dependent variable? G of x. Function notation will always be, so this is really important and it doesn't come easily. Function notation always stands for a value of what? Input or output? Output, a value of the dependent variable given what's in parentheses as the independent variable. So this is function notation. So whenever it says function notation, it's talking about this thing. Like g of x, or h of 2, or h of a plus 2, or whatever it is. It's this thing over here. It always stands for a value of the output variable. For the given input, for whatever the given input is. That's why it's a really powerful notation, because the whole thing stands for a value of output, and then you're staring at the input, you're staring, in parentheses, you're looking at the particular input that gives that output. So you see both values of the correspondence point. You're looking at both values, not the values, but a representation of both values. The input represented there, and then the corresponding output represented as the whole thing. Okay, and what's the rule? Where's the rule? The whole thing on the right side. The rule, it's that formula that generates values of output given values of input. Okay, so if this were just a formula, say y equals this. So if you just had y equals this rule, and there was no box, there was no nothing, what would the domain be? And the domain we talked about last time is all possible values of x, or the input variable. So if it were just a formula, what would be the valid numbers that you could substitute for x and get a valid y? All real numbers, okay? Negatives, positives, 0, fractions, big numbers, small numbers, doesn't matter. There's no x that you can't put into that formula and get a valid value y out. So that would be just as a formula its domain. But what we're really interested is the domain in the context. What values of x make sense as a cutout side length? What values make sense as a cutout side length? So we're really asking about what's the lowest possible value and the greatest possible value and all in between. So what's the least possible value of cutout side length?
0.
Okay. Is 0 valid?
Yes.
Yes. It's just like a sheet of paper. So you can cut out a square of side length 0 by just doing nothing with a sheet of paper. What about x being negative something? Physically impossible to cut out a square with side length negative something. Physically impossible. Okay? So our domain, all possible input values. So domain, say in context, that's the one we care about the most. The lowest possible value is 0. Okay? And that's okay. Now what's the largest possible value for x? 8.5. What do you think? 4.25. So where do we run out of the ability to cut a square? Right there. So the short end is going to limit us. The short end was 8.5, but then we need to cut out 2 squares. So the biggest squares that we could cut out physically would have side length of 4.25, some of you are saying. Do you get a valid box? No, you get a vertical, you fold up the flaps and you get this vertical piece of paper with no volume. Is it physically possible to cut out squares of 4.25 inches? Is it physically possible to cut 2 squares out 4.25 inches or 4 squares out? Yeah, you can do it, right? It's just you're left with this green sheet that you fold up, you don't get a box. But it's mathematically fine. It's physically possible. And then if you were to plug 4.25 as an input into your function, the corresponding output would be 0. This would give you a 0 here, and that's what happens, right? You get a box with 0 volume. Now, can I cut out squares of side length 4.3 inches? If you do that in one corner, so if I cut out a square with side length 4.3 inches, now it's physically impossible to get another square on this corner of 4.3. I can't, once I cut out that much paper, I can't get another square of 4.3 over here. Physically impossible to do it. So the biggest squares that we could cut are 4.25. And we've talked about why we want to include those, because it's physically possible and mathematically sound. In this case of a 0 square and a 4.25 square, we just get a volume of 0, and that's what happens. Okay, so in web work, here's possibilities of how you're going to enter this. You can do less than, equal to, x, less than, equal to. So you need the 2 different symbols there, which combined mean less than or equal to. Or if you want to include your endpoints of the interval like this, you use brackets, 0, 4.25. If you don't want to include the endpoints, say we didn't want to include the 4.25, then you use parentheses. Parentheses means don't include the end. Brackets means do include the end in your interval. Okay? So, not all web work problems are created equal, okay? But, so, these would be the 2 ways. There would be some web work problems that would accept both ways. Almost all the web work problems, I think, will accept this way, using parentheses and brackets. I think there's almost all of them do that. And I think lots of them accept both. Okay? We're going to do one more example. But questions so far on this example or entering domains in web work? If you had 2 intervals, say there was one interval over here that was the domain, and then there was a break, and then there was another interval, they use a capital U. So like this would be 3 to 4 and then you do U, and then maybe I don't want 6 to 10.5. And I do want that. Okay, so this would say, don't include 3, but all the values from 3 up to and including 4. And then start again with values greater than 6, not equal to 6, up to and including 10.5. That would be a way to then express a domain that has 2 intervals. U stands for union. Okay, questions on this one? Okay, so another example. If I gave you the formula y equals 18 minus 0.75x, what's the domain of that? What's the domain of that formula? Y equals 18 minus 0.75x. What are all possible values of x that give a valid y? All real numbers, all real numbers. Without a context, and no square roots or fractions. So where do we get into trouble here? If there was a denominator, so like if you had 1 over x minus 3, you wouldn't quite have all real numbers for that one, because x cannot be 0 or 3? 3. X of 0 is fine. You get negative 1/3. If x is 3, that's when you're trying to divide by 0. Okay? And you can't do that. So this would be x not everything but 3. And then square roots. What's inside a square root has to be 0 or positive. So you'd find the x's, all x values that make whatever's under the square root 0 or positive. That would be how you would find your domain. But here we don't have any issues. There's nothing restricted on x here. Okay? So now I'm going to say that x is time in seconds since flag started to be lowered. And say P of x is the height of the flag in meters. So now we have a context, and now this puts restriction on what makes sense for x to be, this time in seconds since the flag started to be lowering. Started lowering. Okay, so the way to get started is to think about what's my lowest possible value of x, and then what's my highest possible value of x, in order to get this range of x's that make sense. So what would my lowest possible value of x be? So I'm hearing 0. Can x be negative? You can make an argument for it, but just at face value, no. It's like we start the clock when the flag starts to come down. So the lowest possible value is 0. So you could call it, so it's possible to argue that x was negative 3 would be what? 3 seconds before the flag started to be lowered. Okay, but that's not what we're interested in here.
So realistically, if it was going to be negative, it would specify that.
Yeah, you would want to say that. Yeah, it would want to say like the problem would have to specify that times before time equals 0 are valid. Yeah, and if it doesn't do that, then conventionally we just let time starts at 0. Okay, so we've got time 0, and then we're saying what's the greatest possible value of x. So can x just go on indefinitely in terms of giving us a valid output of height? No. So what are we interested in to find the greatest value of x? Yeah, so what's the height going to do? It's going to start at 18 meters here, and then it's going to decrease, and then what's going to kind of put us end to this? Yeah, when the height is 0, right? So for values greater than x, after that, it's going to give you negative values of y, and the flag's not going to go underground. That doesn't make sense. So the domain is giving us values of x that make sense in the context, or up to and including when y equals 0, or the height the flag reaches the ground. So if you do that, you solve for x, you get 24. Include 24 or not? It makes sense to include 24 because that's the time when the height reaches 0. But if you were to include 24.2 and use that function, so a time of 24.2 seconds after the flag started being lowered, that exists. But the problem is that it gives you a negative height, and that's why we don't want it in our domain. So 25 seconds, 30 seconds, it has meaning, but it doesn't work with the way the function is defined because those numbers give a negative value of height, so we don't want those in our domain. Okay, so this would be 0 to 24 seconds, or 0 less than equal to x less than equal to 24. So one of those two are going to work. If this was a question in web work, one of those two, and in many questions, either of those would work. Okay, follow-up questions on domain. Does it make sense? All possible values of the input variable, and we're mostly interested in the context. What is physically possible and makes sense in the context? Questions? Okay, we need more practice with function notation. Okay, really important. What does function notation represent again? A value of the output variable of your function. So page 92 in your book, number 3. Do we have written homework? Okay, so yeah, so I told you to bring Wednesday's homework. So let's fold that up and please leave Wednesday's date on there, please. So it coincides with Blackboard. So name 171, and what was it? The 9th? 9/9. Please keep Wednesday's date, the original date it was due, so it matches up with Blackboard. And please, a clean left edge, no fringe. And then before you write the heading on, please open sides to the right. This is with so many students. These details are helpful, okay? And then when you pass them, let's just go all this way. If you would stack them all oriented just like this, in a stack like this, that would help too. Okay, and as you're doing that, page 92, number 3, listen up. You're going to work A through D, and then I'm going to give you alternate versions of E and F. So you're going to work through A through D, and then look to the screen for the new versions of E and F. Can you pick up the homework? What's that? Yeah. So just pass it all to your right. I don't have a rubber band for you today.
Oh, that's okay. That's okay.
I don't have my bag. They're all in my bag. Work together, talk these out, okay? Okay, so the new part E and F are up there, but take your time on A through D. Really important stuff. We got to get this. And represent the population of Ames K years after 1990. What'd you come up with for that? What's that? H times t plus what? Like this? Okay, so first of all, is that times? So function notation isn't multiplication. This is our notation for the output variable. So it's h of, and what do we think about this? H of t plus k. Daniel, you want something different? He wants h of k. So remember, the function notation gives you the particular output when the input is whatever's in parentheses. So if we want it k years after 1990, that's our input, and we want the population k years after 1990. So it's simply h of k. That's all it is. H of k. How many people got it right? Just I'm curious. Most. Okay. Just that's all it is. It's all right. The meaning of h of k plus 3. So is that the meaning of that? Is that a number of years, or is that a population? H of k plus 3. Is that a number of years or a population? It's a population. It's an output value for what input? K plus 3 years, or k number of years plus 3 number of years. So what's another way to say that? That's the population. K years after 1993. So it's 3 more years, or k years after 1993 is one way you could say that. So it's the population k plus 3 years after 1990, or k years after 1993. I won't write that out. Okay, somebody new. How about we'll just go now. Kaylee. Where's Kaylee? She went to the bathroom. Lucky. Denise. Where's Denise? Okay. Tell me about, we want to represent a population that's 765 more than the population in 1996. What'd you come up with? Here's what she wrote. Agree? So h of 6 would be our population in 1996, and then we want 765 more people than that. Perfect. That's what it is. It's the population that's 765 more than the population in 1996. Very good. Okay. Gary. Where's Gary? Yes, sir. How about this D? We want to represent the change in population from m years after 1990 to m plus 7 years after 1990. Do you get that? So if we wanted a change in population, what would the general structure of our answer be? Just the overall structure to get a change in a quantity of a variable. How do we get a change? Yes, sir? One output value. One output value minus another. Okay, and we're representing output values as h. So this is going to be a change in population. And so to get the change in population, we're going to need final population minus initial. So what is the final population? H of n plus 7. And what's the initial population? The initial population. H of m. H of m. M is the initial time, or m years after 1990, but H of m is initial population. So this would give the change in population over this time period, starting m years after 1990 to m plus 7 years after 1990. How long is that time period? How long is that time period over which we're calculating the change in population? 7 years, right? Isn't that 7 years? Because it's m, and then it's 7 years after m. So another way to say this would be the change in population over the 7-year period. But which 7-year period is it? Starting m years after 1990. So kind of a more fluid way to say this, rather than saying starting m years and ending m plus 7, you could say this is the change in population over the 7-year period, starting m years after 1990. Okay, how did the extra problems go? Where are they? So we want to express the change in population over a period of Z number of years starting in 1991. Did Kaylee come back? Kaylee, how'd this go? You didn't get to that, okay? How about Bryce? Where's Bryce? How about this one? We want the change in population over Z years starting in 1991. So let's do overall structures first. If we want a change in population, what will the overall thing look like? If it's a change in population. Not sure. Is it just going to be H of something? Does that give a change in population? Yeah, so we're going to H of one thing minus H of another. So now we need to be a period of 7 years starting in 1991. So where can we start with that? If it starts in 1991, how can we start working on this here? Christian, if it starts in 1991, okay, but it's a period of Z years starting in the year 1991. So when is it starting? Nope. Starting in 1991. It would be H of 1. Starting in 1991. And then ending H of Z. Is that right? Yeah, no, it's not. It's not at Z years after. It's at Z years after 1991, right? It's the period, the length of the period of time was Z years, and we're starting in 1991, so it should be Z plus 1. That gives a period of Z years starting at 1991. Okay. Did I lose you? Can you? Everyone got it? Can you ask a question? Okay. Express the change in population of Ames over the 8-year period starting at any time after 1990. Any time. Hector, did you get this one?
No, but I can try.
Great. I love it.
H of what variable?
Anyone you want. I didn't specify.
Okay, then X plus 8 minus H of X.
How did you do? What do you think? So he's saying X is this arbitrary time after 1990, and then we want the change population starting at X to 8 years later. H of 8 or X plus 8 years after 1990. So that gives that's it. That gives the population over the 8-year period starting at time X after 1990. Okay. Does it make sense? Anybody have a question? So you can keep there's these. I open the whole set up again, so you have another 24 hours to keep working on these questions. I know there's some like this on the web work, and so it's really important that you have command of function notation in this kind of way. Is that a question?
So, web work, there was like one with like the rate of change, kind of.
Yeah. Okay.
Be over Z plus 1 minus 1.
Well, so let's talk about this. Let's look at this last one. So this is the total change over this 8-year period. So the rate of change would be how much it would have to go up every year so that you would get this total amount of change over 8 years. So how would you get how much it would need to go up every year, 1 year at a time, so that you got this same total change? What would you do?
Would you divide that by 8, X plus 8 minus X?
Yeah, which is basically 8. So yeah, so you can do 8 plus X minus 8, but really it's divided by 8.
I put the whole formula in.
You did what?
I put the whole formula in web work and instead of wrong.
Then something else was wrong. So you put X plus 8 minus X?
Yeah, and then I just put 8 and then it was right.
Well, then something was wrong with the way you did it the first time, because it should count it right both ways.
Really? Because I did it at 2.
Okay. I'd have to look at it. There's a reason, but both x plus 8 minus x and 8 should work, unless there's some special instructions in there. But that should give you the same thing. So that now would be the constant rate of change, or the average rate of change, that would give you how much it would have to change every year in order to see that total change in 8 years. Okay, other questions? Yes, ma'am. Okay. You use parentheses for all real numbers. Use parenthesis, negative infinity, comma, infinity, parenthesis. So whenever you're doing all real numbers, you don't use the less than signs. Use the parentheses, and that should always work. Okay, so I want to start the next part. We got some time here.